my code hand strong.
Hello, welcome to Keep My Code Hand Strong, where today we'll be going over the code briefly for the Arduino Bitcoin ticker project that I recently completed. Sorry about the audio quality, and it sounded like a colo in here, but miner's got a mine. What are you going to do? I as well won't go into the importance of bitcoins or cryptocurrency in general, as it's beyond the scope of this video, but suffice it to say that money is a human technology, and it seems a bit funny that we're using 300-year-old antiquated technology. End rant. Alright, so I've went ahead and put the code on GitHub, so let's go ahead and get the code off the GitHub here. I'll post a link to this GitHub so you can grab it. You can download the zip, or I'm going to go ahead and git clone it, so we'll just copy that and minimize this if I'm able to. There we are. And first, this is a Linux machine. This will be a Linux tutorial. Windows people, as always, you're on your own. So I'm first going to go ahead and create a directory, and we'll just call it BTC. And once we do that, we'll just go ahead and cd into BTC. And once we're in there, we'll go git clone, and then we'll paste the URL we just copied from the git clone page. And once we've, I guess, hit clone is not what we want to do. I guess we try it again with the git clone. See my slow internet in effect here. So once that's done, we should be able to cd into the directory, and try that again here. We've got the two main files there, the Python file, which relays the information that you grabbed from the API that's displaying the current price, and shuttles it over through the serial to your actual Arduino, displaying it on your LCD screen. So we've got the README, and then the Bitcoin, the BTC ticker.ino, which is your Arduino file. So let's go ahead and open up the Arduino and go over that code real quick here. So we've got the first part just goes over the circuit, and we'll go through that briefly. The LCD RS pin is going to be connected to your digital pin 8 on your Arduino. The LCD enable pin to digital pin 6 on your Arduino. The LCD D4 pin to the digital pin 5 on your Arduino. The LCD D5 pin to digital pin 4 on your Arduino. The D6 pin on the LCD to your digital pin 3 on your Arduino. LCD D7 pin to digital 2 pin on your Arduino. The read-write LCD pin going to ground. The LCD pin 16 going to pin 11 on the Arduino. The LCD pin 17 going to pin 10, and pin 18 on the LCD going to pin 9. The potentiometer, both of the ends go to 5 volts and ground respectively, and then put the wiper to pin 3, which is the LCD VO pin, number 3 on the LCD. The next part just initializes the liquid crystal library, and then we tell it to initialize the LCD, and we give it the pins that are controlling that, which are in this case 8, 6, 5, 4, 3, and 2. We then tell it to initialize the backlight, which are using the 9, 10, and 11 pins. In this project I use a common anode. If you were not using a common anode LCD, if you were using a common cathode, you would want to go ahead and comment that out. But because we are using, I'm using a common anode, I'll go ahead and leave that uncommented. Then we get into our setup here. First, we want to go ahead and initialize our output pins for our RGB backlight. So we just tell the pin modes that each of these variables that we defined up here corresponding to a pin, we want to set them as outputs. We then initialize the LCD. Here, in this case, it's a 20 by 4. If you do have a 16 by 2, this is where you'd want to change it to note that. We then go through and set our backlight color to blue in this case. I just like blue, so we're going to go and change it to that. And then we print our initial message before we get any serial data. So this blue screen and the Hack the Planet should show up before we receive any serial data, and regardless if serial data is coming on or not. Then we get into our loop here. We'll go ahead and check for serial data, and if the serial data is available, we want to parse that data, and we're going to parse price, which we name as a variable in our Python script, which we'll get to here shortly. And we'll want to read that until the end of the character. So until the character's end, we'll read the serial. And here we've gone up and set up a conditional statement saying that if the Bitcoin price is below $300, we want to turn and keep the light on red. And then if it is above $300, we'll go ahead and set the light to green here. So if it and you can change where you would change that is right here. You would just put in the dollar amount as the threshold you'd like to see that change, and you could really start tuning this in real nice to where it goes up for the last amount. If the last amount was up higher or lower, you can have it respond like that if you wanted to, but this is just a real quick, simple, dirty implementation of it. So after we've set the light, depending on if the price is below or above $300, we want to go ahead and display on our LCD screen. So first we'll clear the screen, then on the first line we'll print current Bitcoin price, and then we'll go ahead and print on the third line because it starts with 0. So the third line at position number 6 we'll print the $, and then we'll set the cursor to the third line 7th position and we'll print price, and you notice it's not in parentheses here, so that means it's an actual variable, and it's pulling that variable from the Python script, which we'll go over in just a second. This stuff at the bottom is unneeded if you're using a common cathode LCD. I again am using a common anode, so this is just telling it to do the right thing. You will not need this if you're using a common cathode, so just go ahead and disregard that if that's the case. So that's pretty much the script here. You can check it, verify, make sure that everything's working, and it's going to upload. See, we do have a problem here. So the liquid crystal does not have a name. Okay, perfect. So I have not installed that library on here, so we'll just disregard that. But you would upload it here, and once you upload the script, and we'll go ahead and upload it. I've got it actually going on another computer, as you can see here. So once you upload the script there, it'll go ahead and go into our blue screen with the Hack the Planet on there, and it is not receiving any serial data because we've not started our Python script. So let's go over that Python script real quick. So let's just cat that file and see what's going on. It's not a very large program, as you can see here. First we go ahead and import the requests library, then we'll import the serial library and import time, so we can increment how often we want to make our calls to the API to get our new data. Then we'll go ahead and set a variable s, and we'll make that equal to serial.serial, and then we'll go ahead and change our baud rate to 9600 here, baud, and set your TTY. This is mine, yours may be different. You can go into your Arduino and find out on your serial monitor what serial port you're using, so just input that here, change that if you need to change it. We then tell it to sleep for 2, and then we give it a conditional statement here. If S, which is our port here, our serial port, is open, while true, we want to go and grab from this site right here, and there are many sites that have Bitcoin APIs. This one did not require any authentication, so it's really easy to implement. So and you can as well change your dollar if you're euro or whatever currency, national currency used, just change it here. Us being in the US, we'll use the fiat dollars, so we'll put that there. And so while r equals request.get, we'll say r.json, so we want it to it's going to expect JSON, and then we'll say we want it to parse out the last from that JSON, and then we're calling it price, so we say price equals r.json, the JSON, and we're picking out that last and we're printing it out. So we'll print that out and we'll write the price, and the price is what's going to come over into our Arduino sketch. So that's what's actually going to get pushed. That's the variable that's being called. It's going to get pushed over there, and then we tell it to sleep for 25, and that's going to let it rest, and then in 25 it's going to come back and do the same thing. So every 25 seconds it's going to go and request new data from that. So let's go ahead and try that Python script here, and there it goes. It's instantiating it there, and it's getting serial data. So it's telling us that the current price for Bitcoins at this very moment is 291.74 cents. So and it, like I said, will change every 25 seconds or so, 30 seconds. It'll receive new serial, it'll make another request on there, get new data. Like I said, you could really tune it in and do some really neat things. This is just a quick, dirty implementation of it. I do plan on doing a model with the ESP8266 and kind of making it where it's not actually physically hooked up to the serial cable, so look for that project here in the near future. But like I said, I'll go ahead and put the code to put the link to the GitHub on my webpage, so you can go and check that out and get it, play with it yourself, improve upon it. We'll go ahead and close it with that. So I thank you for watching, and until next time, I'll be keeping my code hand strong.